This is the EPRI Welds 2 Senior Design 2 Expo poster.
The main objective of the project includes creating a LabVIEW project that may analyze collected data, displaying timestamps when issue indicators are detected, as well as generating a report at the end of the weld run. The requirements include using a microphone and an accelerometer to detect the issue indicator, creating a unified LabVIEW project, as well as displaying the pop-up when the issue indicators are detected.
The overall design consists of 3 different microphones connected to the Behringer audio interface, as well as 2 accelerometers connected to the Arduino Teensy. These are the models that were created throughout the project.
This is the flow chart of expected program functionality. First, the user selects the file name and location to save the data. The program then waits for the user to select the appropriate audio inputs. Once the Proceed to Step 2 button has been pressed, the program waits for the start signal from the Liberty power supply. Input is then read and issue indicators are flagged accordingly. Issue indicators are displayed as pop-ups in real time and as a report at the end of the weld. This is the front panel of our main deliverable. All user input is handled in steps 0 and 1, while step 2 handles data input and processing. All input is graphed to verify that the program is operating as expected, and a timestamp array and flag array is shown to ensure proper functionality. This is the example of our microphone peak comparison. Drips are detected by comparing the inputs from the microphones. The Omni microphone picks up background noise and pulsing, but not dripping. The Uni microphone picks up pulsing and dripping. By comparing the timestamps of peaks, it is possible to determine if the peak is a drip, welding noise, or background noise.
While the initial plan was to build a filter to remove machine pulsing, it was found that the drip noise was spread across the entire frequency spectrum rather than a single band. Real-time integration of the filter was unsuccessful due to complications in the LabVIEW integration.
This image shows the microphones during a high weld. If a peak is greater than a user-defined level, a timestamp for that value is generated. The timestamps for the Uni-mic input is compared to the Omni-mic input, and when they do not match, the timestamp is determined as a drip. This image shows the accelerometers during a low weld. The z-axes of each accelerometer are compared and used to determine a low wire feed issue. Once determined, a timestamp is generated.
Future integration should include comparisons between the Uni, Contact, and Omni microphones in an effort to reduce machine pulses and background noise. A feedback loop through the Liberty power supply for auto correction should be developed if possible. And finally, the addition of pop-up windows during real-time detection should be integrated when an issue indicator is verified.